Okay, tonight's video is focusing on 7-2, which is powers of 10 in scientific notation. So if you can please find that, and please get out your vocab sheet. We're going to jump right into this. Now you should have already had the first two completed from yesterday, and one of the things that you learned yesterday that's going to be very helpful is this idea of a negative exponent. So whenever you have a negative exponent, like 3 to the negative 2 power, just want to reiterate that never ever means a negative number. A lot of kids want to say that's like 3 squared, which is 9, and try to think of it as negative 9. But by definition, this means 1 over 3 squared. So this really is 1/9. Okay, that's really going to come in handy with what we're doing today. So today we're talking about the positive integer exponent and the negative integer exponent. The very first one is pretty easy. It says if n is a positive integer, find the value of 10 to the nth by starting with 1 and moving the decimal point n places to the right. Okay, so in our example, 10 to the 4th really means 10 times 10 times 10 times 10, 4 times. But by definition, it means start with the number 1, and we're going to move the decimal 4 places to the right. So this really becomes the number 10,000. So in your book, it looks like this. The definition says, if n is a positive integer, find the value of 10 to the nth by starting with the number 1, and we get that by this 1, and moving it 4 places to the right. Okay, so over here, 10 to the 7th would mean 1, and then we have to move the decimal 7 places. So in other words, we have to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. So that's going to become the number 10 million. Okay. All right, negative exponent says if n is a positive integer, find the value of 10 to the negative n by starting with 1 and moving the decimal point n places to the left. So when we have something like 10 to the negative 4th, in this case we start with 1, the number 1, and notice this time when I'm starting with 1, I'm moving it way over here because I know I'm going to move the decimal to the left and I want to have space. But notice that the decimal starts behind 1. So when we move 4 places, notice that it's really only going to be adding 3 zeros, because the first movement gets us behind the 1. So there's 1, 2, 3, 4. So it's a little bit trickier for kids when they start dealing with moving the other direction. Okay, so some of the work we're going to do, if we had 10 to the negative 6th, that means we start with 1 back here and we're going to move 6 places. So 1, 2, 3, 4, 5, 6, which means we have to fill in 5 zeros there to get our number. Okay, so you're going to have to go in both directions in your work today. So you'll have to evaluate something like this and get to here, but you'll also be given something like this, and you will have to go the other direction and write that as 10 to what power? Well, you can tell that since it's a very small number, a number less than 1, our exponent's going to be negative. And then to figure out what that is, you go back here and you figure out how many places did the decimal have to move. So notice that since it had to go 3 to the left, it's going to look like this. Okay? All right, and then we get to scientific notation. And I'm really not sure how much scientific notation you've done in science so far, but scientific notation is a method of writing numbers so that very large or very small numbers can be written in an accurate way without losing a decimal point. So I'm sure you've all been in a situation where you've been reading a number out of a textbook or somewhere and you've read it, you've seen this, and sometimes your eyes start to cross and they kind of bug out as you're counting how many zeros there are. If you can imagine, if scientists are using many calculations with numbers like this, one miscounting of a zero could be a significant distance difference or a significant measurement error. And so scientists have used scientific notation as an easier way to keep track of numbers so that they don't have those errors with zeros. So in scientific notation, there's a few rules. The first rule is that the first part of the number, so I'm going to write a number in scientific notation. The first rule is that this first number has to be between 1 and 10. It has to be a value between 1 and 10. So 3.5 fits that rule. And the second rule is that the second part of the scientific notation has to be a power of 10. Okay, so that's kind of the standard that scientists have come up with, is that we're going to write our numbers in two parts. The first part has to be a number between 1 and 10. The second part has to be a power of 10. Okay, so then in this case, we learned previously that 10 to the 11th power is taking the number 1 and moving the decimal 11 places to the right. So if we covered this up, isn't 3.5 times 1 just 3.5? So we're going to start with this, and now we're going to move the decimal 11 places to the right. Okay, so I'll let you guys do that. When you move it 11 places, there's 1. So basically you have to add 10 zeros. So there's 3, there's 6, there's 9, there's 10. And then you go through and put your commas in. So this is going to be 350 billion. Hundreds, thousands, millions, billions. Yep, 350 billion. Okay, so as an example over here, let's do this. We're going to put this number into scientific notation. So the first step is you need to locate what's called significant digits. And the significant digits are, in this case, 4, 5, and 7. They're all of the digits that are not including this string of zeros. And we call them significant because 4, 5, 7 is really what's going to give this number definition and specifics. So we take those significant digits of 4, 5, 7 and we first write them as a number between 1 and 10. So 4.57 is how we're going to have to place a decimal point so that this becomes a value between 1 and 10. Then we figure out what power of 10 are we going to have to multiply by so that 4.57 becomes this. So I tell kids to kind of mentally place your decimal place right here, and you need to ask yourself to go from here to here, how many places did the decimal have to move? 1, 2, 3, 4, 5, 6. Do you see that it's got to go to the left 6 places? So that means it's going to be 10 to the negative 6th power. Okay. One of the problems that you're going to face is something that looks like this. And it's going to say this number right now looks like scientific notation, but it's not. And the reason it's not is because this leading number, remember, has to be a digit between 1 and 10. So it's going to ask you to turn this number into scientific notation. Okay, so the first thing we do is we take our significant digits of 1968 and we write them as 1.968. But when the number was here, when the decimal was here, our number said to move it 3 places to the left. So now that we're starting out here, how is our exponent of 10 going to change? Well, notice that we already just moved it 2 of those places to the left. So that's going to change to -1 because now we only need to move it 1 place to the left to be the same as what it was over here. Okay. All right. What I'd like you to do now is in your notebook, if you can please find the value of this. Find the value of this. And write these ones in scientific notation. Okay, so I'd like you to translate these 2 numbers, scientifics, to numbers, and these 2 numbers to scientific notation. And lastly, to finish up, if you have your textbook, on page 454, you're going to do checkpoint 5. If you don't have your book, it looks like this. You need to take all of these numbers and order them from least to greatest. Okay, so if you need to pause the video, but you're going to order these from least to greatest. All right, thank you. Have a good night.